everyone. So today we're just going to learn how to convert between moles of a substance and grams of a substance. And before I get into actual any unit conversions, in order to convert between the moles of a substance and the grams of a substance or vice versa, you first need the molar mass of said substance. So in the first question we have determine the mass in grams found in 2.50 moles of sodium metal. And if you see right here, you're given the molar mass. So if you don't know how to already find molar mass or calculate it, make sure you look at the video that I already uploaded that shows that process. But we have our molar mass to be 23.0 grams per mole. And remember, this molar mass is unique to sodium only. So this is the molar mass that you use to convert from moles of sodium metal to grams of sodium metal, or vice versa. So here, back to the actual unit conversion, you've been given 2.5 moles of sodium, and you're asked to determine the mass in grams. So the unit that you're starting with is moles of sodium, moles of Na, and you're asked to convert it into grams. So the final unit you should end up with is going to be grams of sodium. And remember, the way that you convert from moles to grams or grams to moles of any substance is going to be using this molar mass. Now, I typically rewrite all of my molar masses in a certain way, so I'm just going to show you guys how to rewrite that. So I'm going to put the mass up top, 23.0 grams specifically of sodium, that's Na, and I put that over 1 mole of sodium. So what this is saying is for every 23 grams of sodium that I have, I should end up having 1 mole of sodium. That's what this molar mass represents. So I have my units that I start with, I have the number of said unit, and I have the way to convert it from my starting unit, which is moles, and my final unit, which is grams, which I'm going to use the molar mass for that. So when I start off a problem, I always write what I've been given, which is 2.50 moles of sodium. And my ultimate goal is to get rid of this unit, cancel it out, and convert it into grams of sodium. And so if I just multiply it by this fraction right now, it will be 23.0 grams of Na over 1 mole of Na. And so what we're saying is we're multiplying by the numerator and dividing by the denominator. So when you divide the same two units, moles over moles, they cancel out. And I'm left with grams of sodium, which is what I was asked to determine. And so I've already completed the unit conversion. I just need to plug in my numbers. So I'm multiplying 2.5 times 23, and I'm dividing it by 1, but you don't really need to write that down. So when you plug this in, you'll do 2.5 times 23, and so you'll get 57.5, which is the mass of sodium in grams. So the final answer would be 57.5 grams of Na. And so this would be the final answer. I've converted from moles of sodium to grams of sodium, and that was done by dividing moles by moles. And remember, for every single unit conversion from moles to grams, you're going to use the substance's respective molar mass. So another example, you are given 45.7 grams of bromine, and you're asked to determine the amount of moles present. Here you've already been given the molar mass of bromine, which is Br2. It's found to be 160 grams per mole. And if I want to rewrite that molar mass into the format that I like, I keep grams up top. So it'll be 160 grams of Br2 over 1 mole of Br2. So if I have 1 mole of Br2, then that means I have 160 grams of Br2, and vice versa. And the actual unit conversion that I'm being asked to complete is going from grams of bromine, this is what I've been given, to moles of bromine. So I already have the unit converter to make that conversion happen. That's the molar mass. So I can start setting this up. Always write what you've been given first. So it would be 45.7 grams of Br2. And so in the last example, I kept this unit conversion exactly the same because I wanted to divide by moles. However, now my starting unit is grams of bromine, and I ultimately want to get rid of that unit. The only way to get rid of a unit is to divide by the same exact unit. So I'm going to flip this unit conversion. All the numbers are going to be the same. I'm just flipping the positions of each one. So moles of Br2 is going to be up top, 1 mole of Br2. And you're dividing by the molar mass now. So you'll have 160 grams of Br2 at the bottom. And so now you're multiplying by moles of Br2 and dividing by grams of Br2, or simply just dividing by the molar mass. So when grams of Br2 is divided by grams of Br2, the units cancel out. And what you're left with in terms of numbers is 45.7 times 1 divided by 160, with your units left behind being moles of Br2. So when I plug that into the calculator, it'll be 45.7 divided by 160, and you'll get 0.28, I'm going to say 6 moles of bromine, or Br2. 0.286 moles of Br2. And this would be the final answer. So another problem, pretty similar in comparison to it. We're asked to find out how many moles there are in 252.0 grams of magnesium oxide. So this is what you start off with. And you're asked to determine the amount of moles. So the process should be going from grams of magnesium oxide, that's MgO, see it's written right here, and you're asked to determine or convert it into moles of magnesium oxide, MgO. The molar mass has been given to us. I'll rewrite it in the same exact format we've been using. So it'll be 40.3 grams of MgO per 1 mole of MgO. I am asked to go from grams to moles of magnesium oxide, and I have magnesium oxide's molar mass, so I can start setting that up. Always write what you've been given first. So you'll start by writing 252.0 grams of magnesium oxide. And so the unit that you're trying to get rid of or cancel out should be grams of magnesium oxide, and you want to end up keeping moles of magnesium oxide. Right now at this current state, with the unit conversion, you would be multiplying by grams of magnesium oxide and dividing by moles of magnesium oxide. We're trying to do the opposite, so we're going to flip this. So you'll put moles up top, 1 mole of MgO, over the molar mass, which is 40.3 grams of MgO. I haven't changed anything about this. I've just kind of flipped it. I've put moles up top and grams at the bottom. So grams of magnesium oxide cancels with grams of magnesium oxide, and the unit that you're left with is moles of magnesium oxide. And all you have to do is just divide 252 by 40.3. And your final answer would be 6.25 moles of MgO. Okay. Final one that we have. You're given 0.525 moles of lithium phosphate, that's Li3PO4, and you're asked to determine the mass in grams given the molar mass, which is 115.8 grams per mole. So the unit conversion that we've been asked to do is moles of lithium phosphate, that's Li3PO4, to grams of lithium phosphate. I'll go ahead and rewrite the molar mass. So I'm going to rewrite it as 115.8 grams of lithium phosphate, Li3PO4, over 1 mole of lithium phosphate. So I have the unit conversion that I want to accomplish already written out. I have the unit converter between those two units, that's lithium phosphate's molar mass. All I have to do now is just set it up, so always write what you've been given, which is 0.525 moles of lithium phosphate. And the ultimate goal is to divide by moles of Li3PO4 or cancel that unit out. In our unit conversion, moles of lithium phosphate is already at the bottom, aka you'd be dividing by it. So you're going to keep this exactly the same. So you do times 115.8 grams of Li3PO4 over or divided by 1 mole of Li3PO4. And so moles of lithium phosphate and moles of lithium phosphate end up canceling out. And what you're left with is grams of lithium phosphate. The entire calculation that you're doing is going to be 0.525 times 115.8 and then divided by 1, but again, you wouldn't really include that. So you do 0.525 times 115.8 and you'd get 60.8 grams of lithium phosphate. And that's how you calculate, or that's how you convert from grams to moles of any substance when the molar mass is given. Again, if you do not know how to calculate this unit right here, this molar mass, I would suggest going to my molar mass calculating video. If you already know and you understand this, you're good to go.